You know when you're in the middle of a movie marathon, or maybe a last-minute online shopping spree, and everything just works? It's amazing, right? No buffering, no crashing, just a totally seamless experience. Well, we all kind of take that for granted, but today we're going to pull back the curtain on the invisible tech that makes it all possible.
I mean, seriously, think about it for a second. Millions of people all hitting play at pretty much the same time. How on earth does a service like Netflix or YouTube or Amazon not just completely collapse under all that pressure? Well, the answer is this brilliant concept called load balancing.
To really get why this is so important, just imagine the alternative for a minute. Picture all 1 million of those requests hammering a single, lonely server. It would be an absolute disaster. That one server would be completely and totally overwhelmed in seconds.
So what happens then? Well, you'd get stuck in a massive digital traffic jam. Pages would take forever to load, you'd start seeing those super frustrating timeout errors, and then, boom, the whole service would just go down. This is the fundamental problem that every single major internet service has to solve.
And this, right here, is our hero, load balancing. It's the elegant solution to that digital traffic jam. And at its core, the idea is actually pretty simple. Instead of forcing everyone down the same clogged-up road, you intelligently spread all that traffic across a whole bunch of different roads, or, in this case, servers.
Yeah, probably the best way to think about a load balancer is as a really smart and efficient traffic controller. It just sits out in front of all the servers, and its only job is to direct every single incoming request to exactly the right place at the right time.
Let's make this even simpler. Picture a super popular restaurant on a Saturday night. It's packed, but it only has one chef. You can see where this is going, right? That chef would get buried in orders, the kitchen would grind to a halt, and you'd have a lot of angry, hungry customers. That's our single server nightmare.
Now this is where the load balancer comes in. It's like the restaurant's savvy manager. Instead of just letting that one chef get totally overwhelmed, the manager looks at all the incoming orders, the requests, and intelligently assigns them to a whole team of available chefs, who are our servers. And the result? Every order gets handled quickly, and everybody gets their food fast. Simple.
Okay, but here's where it gets interesting, because not all of these managers are the same. You can break them down in a couple of key ways, starting with just how deeply they look at the traffic they're directing.
So on one side, you have Layer 4 load balancers. Think of these like a postman. They don't care what's inside the package. They just look at the address on the outside, the IP and port, and forward it on. It's super fast, very simple. But then on the other side, you have a Layer 7 load balancer. This one's more like a librarian. It actually opens up the request to see what it's about. It reads the URL, the user cookies, all that stuff, and uses that information to send it to a very specific, specialized server. Just like a librarian directing you to the right section of the library.
Okay, so that's what these controllers look at. But what about the how? How are these things actually put into action in the real world? Well, there are really three main ways. First up, you've got the hardware load balancer. This is a physical, beefy, high-performance box that you find in a huge enterprise data center, for a bank or a major telecom company. It's a powerhouse, incredibly fast and reliable, but it's also really expensive and not very flexible. Then you have a totally different approach, the software load balancer. This isn't a special piece of hardware at all. It's just a program, like NGINX or Proxy, that you can install on any standard server. And that makes it incredibly flexible and easy to configure, which is why it's a huge favorite for startups and modern cloud apps. And that brings us to the modern approach, cloud load balancers. These are services from providers like Amazon Web Services or Google Cloud that are completely managed for you. They just scale up or down automatically depending on your traffic, and you only pay for what you use. They're pretty much perfect for today's super dynamic, microservice-based world.
So, to just quickly recap, you've got the powerhouse hardware for big enterprises, the flexible software for adaptability, and the hands-off, scalable cloud option for pretty much all modern applications. Each one has its place, it just depends on what you need.
All right, so this is the really cool part. How does our smart manager, our load balancer, actually decide which server or which chef gets the very next request? It's not random. It follows a very specific set of rules, or what we call algorithms.
These algorithms basically fall into two main camps. On one side, you have static algorithms. These follow a fixed, preset pattern that never changes. They're simple, they're predictable. And then you have dynamic algorithms, which are way smarter. They actually look at the real-time status of each server and adapt their decisions on the fly.
The most common static rule, the one everybody learns first, is called round robin. And it's exactly as simple as it sounds. The first request goes to server A, the second to server B, the third to C, and then it just loops right back around to A again. It's predictable and works pretty well if all your traffic is uniform.
But the dynamic rules, that's where the real intelligence is. The least connections method is great. It sends the new request to whichever server has the fewest people using it right now. Least response time is even cooler. It sends it to the server that's physically responding the fastest at that exact moment. And then resource-based methods go even deeper, checking the actual CPU and memory load on each server before deciding. It's just like our manager peeking into the kitchen to see which chef has the lightest workload.
Okay, so we've gone through a lot of the technical stuff, the layers, the algorithms, the deployment types, but what does it all mean? Why should we care about this unseen hero? What's the bottom line for us, the people actually using these apps every day?
Well, it all comes down to these 4 massive benefits. First, high availability. That means if one server completely fails, the load balancer just instantly stops sending traffic there. You, the user, never even notice. Then there's scalability, which lets services handle those huge sudden traffic spikes. Think Black Friday sales. Performance is a big one. You always get faster responses because you're always being sent to the healthiest, fastest server. And maybe the coolest of all is zero downtime updates. This means engineers can upgrade and improve the apps we love without ever having to take them offline. When you step back, it's pretty clear. Without load balancing, the internet as we know it just couldn't exist. It is that silent, absolutely essential piece of the puzzle that keeps our complicated digital world running fast, reliably, and just always on.
So, I'll leave you with this thought. The next time you're streaming, or shopping, or just browsing the web without a single glitch or a moment of lag, maybe take a second to appreciate that elegant, invisible dance of requests and servers happening behind the scenes. And maybe you'll think of that unseen hero, that smart traffic controller that's making it all possible.